Cyclonic and anticyclonic system. So how cyclonic system develop and how anticyclonic system develop. Hello guys, so we heard of cyclonic and anticyclonic system. Cyclonic system means low pressure system, anticyclonic means high pressure system. So how cyclonic system develop and how anticyclonic system develop, and what are the consequences of cyclonic and anticyclonic atmospheric system. Let's observe the cyclonic system first. In the case of cyclonic system, low pressure is at the center, which is surrounded by high pressure. Now, because of the low pressure, the wind and the air is attracted towards it, and the inward flow or convergence center of the wind arise, and this convergence resulting into spiral or rotatory wind system. In northern hemisphere, due to Coriolis effect, wind turn towards the anti-clockwise direction, while in the southern hemisphere in cyclonic system, wind rotate in the clockwise direction. So now how these cyclonic winds actually developed. So there are three reasons for cyclonic wind development. One is the convectional heating. Whenever strong heating happens over a landmass, what happens? Air gets warmed up and rises upward and creating a low pressure areas, and the low pressure turn out to be a cyclonic system. And generally in case of tropical water bodies, it is happening more, and that produces a tropical cyclone, and the wind speed becomes so strong in the case of tropical cyclone, it crosses above 200 kilometers per hour also and become a tropical cyclonic storm, and it is a big hazards. Okay, and locally these hazards known by different names called as typhoons, hurricanes, and willy willy, etc., etc. Now, in case of these low pressures developed over the land masses due to tropical characteristics, it may turn into a tornadoes, dust storms, or a case of the other strong winds. Now, what is the impact of this cyclonic system? Is it only developing in tropical areas? No, it can develop in the temperate areas. The reason for temperate areas is not strong heating, but the meeting of cold and the warm air masses, and that is called fronts. So in case of fronts at 30 degree to 60 degree, cold air from Arctic regions and the warm air from tropical regions meet, and high chances of front formation. And the front, what happened at the front? At front, the cold air is denser, try to sink, and the warm air is lighter, try to rise. As a result, your front become wavy in nature, and this wave, that's what your temperate cyclone called as wave cyclone or called extra tropical cyclone. Now in this case, the warm air try to rise upward and cold air try to sink towards the ground. Now in this phase, well developed temperate cyclone get developed and define the weather condition of temperate areas. So you might have heard when the low pressure get more intensely low, within 24 hours 24 millibars of pressure falls, then this cyclonic system will, or this temperate cyclone called as bomb cyclone, and the process called bombogenesis, and it is causing havoc in the colder countries of North America or Europe or Russia. So you might have seen in the recent times. Now the case of anticyclones. What are anticyclones? Just opposite of a cyclonic system. It's bigger than the cyclone. In case of anticyclone, high pressure centers are existing, which is surrounded by low pressure. Here the wind is also moving in a circular fashion, but not inward but outward. So this divergence wind is responsible for these anticyclonic system. Now because of high pressure center, not only divergence wind, there is a sinking of air is also reported. In northern hemisphere, this anticyclone rotate in a clockwise direction, while in the southern hemisphere rotate in the anti-clockwise direction. So what are the reasons for this anticyclone development? What are the different types? There are 3-4 main types of anticyclones. One is a warm anticyclone, which present at 30 degree latitude at subtropical highs, just located over the hot desert topography. Second is the cold anticyclones, which is found at the polar highs over Arctic and Antarctic region. These are permanent anticyclonic areas, warm anticyclones and the cold anticyclones. And third situation arises in the winters over the large land masses. So what happens in winters? High radiative losses dominate, and because of high radiative loss, land become cooler. Cooler land will have cooler air. Cooler air is denser and will sink and maintain high pressure. So as a result, in winter season over land masses, we have a winter or anticyclonic condition. For example, North India in winters have anticyclones called winter anticyclone, or Himalayan Tibetan zone in the winters have the high pressure zone, we call that is also an anticyclone. Even anticyclone also arise due to shifting of the high pressure belts actually. In winters, high pressures of the subtropical area shift upward towards the pole and get established over the land. It happened in North America too. Or in winters is possible your polar highs of Arctic Antarctic region move towards the equator and get established over the land. And because of shifting of polar rise and subtropical highs between the land and sea, also the anticyclonic condition get established. So what is an impact of the cyclonic and anticyclonic conditions? So cyclonic conditions are causing rain, anticyclonic conditions are causing dryness. Cyclonic conditions are a convergence here and anticyclonic is a divergence here. So cyclone is responsible for thunderstorm activity and atmospheric instability, and anticyclones are responsible for atmospheric stability, dryness, desert formation and so on. Thank you all of you. Take care. Bye.